Hello, math students. We're going to have another lesson today about solving equations, but today we're going to have an option of getting some different kinds of answers. Typically, when we solve equations, we get one answer. We call that a solution. However, today, we can sometimes get problems that have infinitely many solutions, or we might have a problem that doesn't have any solution at all. So when we get a problem that has no solution, that means that when I solve my equation, I get all the way down to, remember, we always try to get the variable by itself. Sometimes the variables just go away. If there's no variables left, and we have a sentence, an equation, that can never be true, that's when we're going to get a no solution. So if we end up with something like 5 equals 7, well, no, it doesn't. So when we get an answer like that, this is the symbol we're going to use. It's just a 0 with a slash through it. It's called the empty set or no solution. If you want to write out the words no solution, you certainly can, but that 0 with the slash through it works just as well. It's faster. Sometimes we'll solve an equation just like we talked about in the last one, but we'll get an equation, a number sentence, that is always true. So we solve it, all of the variables cancel out, and we'll get something like 10 equals 10. And yeah, 10 does equal 10. It always equals 10. So that's going to be a problem where any number will work in that equation. So we'll say all real numbers would be our solutions. And we have a fancy way of writing that too, just like we have the symbol for no solution. This fancy R is what we use for any real number. It's for the real number set. And usually we don't try to do like the whole double R thing. We just do a double stem, capital R. That stands for any real number. So again, sometimes when we're solving an equation, we will just get one solution. In fact, most of the time, that's what we get. Occasionally, we get these other options where we might have no solution or infinitely many solutions. Now, again, when that infinitely many solutions comes up, that's where we get any real number. Please don't use the infinity sign. When you get into Algebra 2, you'll see why. It's not that the answer is infinity. There are infinitely many because any number will work. But right now, let's just do a couple of problems where we're going to look at problems where it's not going to be true for anything. So we're going to get false statements at the end, like 0 equals 2. So I've got a couple of problems all worked out here already. My equation is 3 minus 4x equals negative 7x minus 4x. So from our last lesson, I would say, well, which variable is smaller? Oh, they happen to be exactly the same. So let's add 4x to both sides. When I do that, those x's are going to go away, and those x's are going to go away. And when that happens, I get that 3 equals negative 7, but it doesn't. That's not true. That's when we get no solution for an answer. So I would want to see you write this part to show the part that's not true, and then you write the no solution symbol to say that there isn't anything that's going to work. In this problem, we've got some distribution. So we would start by doing 1/2 times 10x and 1/2 times 7. And we would get 5x plus 7 over 2 is the same as 1/2 of 7. That'd be 3.5. But again, now that I see this, my x's are exactly the same. So to get rid of those 5x's, I would just subtract 5x. But again, that's going to cancel out and that's going to cancel out. So what I'm left with is that 7 over 2, or 3.5, is equal to 0. But it's not. That's not a true statement. So again, we are going to get no solution for our answer on that. Now we're going to look at some of those problems where we'll get infinitely many solutions. Right? So these are the ones that have a true statement when we finish it up. So like 5 equals 5. And we'll take a look at how that plays out. So in this problem, we're going to distribute our 3 right? So we had, that'll be a 12x minus 3. And the other side of the equation is exactly the same. When it matches exactly, you should be watching for any time when the variables are exactly the same. But if the entire equation is the same, that can kind of give us this other situation. So when I do that, I'm left with -3 equals -3. Now the thing is, that is true. That's always true. So we're going to get any real number, right? Or that double stem capital R. Any real number means that any number you could possibly think of will work. You could put 17 in for X, it'll work. You could put in -40, it'll work. You could put in any number you can think of and it will always, always, always work. All right, this time we've got a double distribution. So we're going to distribute the 2 and we'll distribute the 4. And let's see what we get. So I'm going to get 4x minus 6 and 4x minus 6. And again, when I say which variable is smaller, they're exactly the same. So they're both actually -6x. And to get rid of those, we would use a +6x. That's going to cancel, that's going to cancel. When that happens, we get 4 equals 4, which is true. And we know it's true, and it's always true. So we get that fancy R. Any real number will work. The special cases are the ones where all of the variables go away. If the variables don't go away, you just get one answer. That's typical. Now, I have a couple of problems that I would like you to write down as examples. If you don't have a notebook out right now, pause the video, get your notebook out. A couple of problems that I want you to have as examples to look at later. So in number 1, distributing a 1/5 shouldn't freak you out. 1/5 of 25x, that's just saying 25x divided by 5. That's just 5x. And 1/5 of 10. 10 divided by 5 is 2. And again, as soon as I see that I've got exactly the same thing, I know that some of you right now know that this is any real number, and that's great. Please take one more step. Get your variables to go away. We want to always have all the variables either all together or gone when we're doing equations like this. So when I subtract my 5x, I'm going to get that 2 equals 2. And yes, it does. Always, there's no variable here. This is any real number. In number 2, again, you should be able to see right now, the variables match, but the other stuff doesn't. This is not going to be an any real number kind of a situation. In fact, I would change this subtracting 5 to keep change, right? We're going to subtract the 3x, and those are gone. So I have -5 equals 7, but it doesn't. Again, there's no variable. You don't just keep an x there just because you want one. They went away. They all canceled out. This is not true. This is a no solution. In number 3, before we can decide if we're going to have a special case, we have to distribute. So I'm going to get 12 minus 36x equals 12 minus 36x. Exactly the same on both sides. Should be a giveaway right now. I'm going to get rid of my x's. I'm going to add 36x. And I just get that 12 equals 12. And it does. And there's no variables left. Any real number. Distributing a 1/4. I'm going to have 1/4 of 12. That's like 12 divided by 4. That's 3. I'll just keep that as a minus for a second. 1/4 of 8x is 2x. Okay, the x's do match. Remember that this really is a -2x. -2x on both sides. So when I add 2x, those go away. So I get 3 equals, please think about what's really on the other side. I had a -2x, I added 2x. There is a 0 there. It's not just blank, but that's not a true statement. So no solution. Keep in mind, this does not typically happen. It happens occasionally, but most of the time we do get one answer, just like all of the other equations that we've solved before today. Today, we're going to have a whole bunch that are like this to practice what these kind of problems can do, but know that it's not going to be like all the time. In this example, I would put a 1 in front of those variables, in front of the p's, and then I would change my 4 to plus a negative. So I'm going to subtract 1p and subtract 1p. They're both going to go away. So I have that negative 4 equals negative 9. Nope, it does not. No solution. In this problem, here's my 12 equals negative 4 times the negative 6x is positive 24x. And negative 4 times the negative 3 is positive 12. Please realize there's only one thing with x's. This is not going to be a special case. Just because the 12s match doesn't mean it all goes away. Because the x's are all together, I don't have to move my 24x at all, but I will subtract this 12x, or this 12, I'm sorry, and subtract that 12. So again, this does go away on the left-hand side, but there's still a 0 there. Don't just leave it blank. And then I have to divide by 24. Some people get so into the habit in this section of thinking that everything has to be any real number or no solution. This getting an answer of 0 kind of throws some people off, but it's just a regular equation to solve. Here we go, last one of these. Kind of a lot going on in this problem. So negative 5 times 1 is going to be a negative 5. Let me change that with the keep, change. Negative 5 times a negative 5x is positive 25x. 5 times a negative 8x is a negative 40x. And 5 times a negative 2 is negative 10. Now that we've got our distribution done, let's clean this up. If I've got more than 2 things on a side, probably something goes together. And in fact, on the right-hand side, there's only 2 things, but they still go together. So when I combine my x's, 25x and negative 40x is going to be a negative 15x. And then negative 5 and negative 10 is going to be a negative 15. On the right side, negative 4x and negative 8x is just negative 12x. Now, think back to the last lesson. Look at those x's. Which one's smaller? Is negative 15 smaller or is negative 12 smaller? It's negative 15. So we're going to add 15x to get rid of this one. It's the opposite of negative 15x. So when we add 15x here, I will have negative 15 equals positive 3x. Again, because the variables are not going away, this is not one of my special answers. It's just a single answer. Here's the last thing for today. I would want you to be able to, after you've practiced a bunch of these problems, be able to write equations that would give you a no solution. Remember, no solution problems have the variables go away, but the other stuff is different, right? So if I would write a no solution kind of a problem, I would have like 2x plus 1 equals 2x, variables match, plus something else. If I would solve that, I would get 1 equals 3, and it doesn't. That's a no solution. If I want infinitely many solutions, that just means it's exactly the same. You don't have to get fancy. You don't have to write a really big, long problem and see if you can get stuff to cancel out. You can just write something like 2x plus 1 equals 2x plus 1. That will give me infinitely many solutions because it's exactly the same on both sides. For my last one, if I just want to have one solution, just make sure your variables don't match. Or even easier, just put variables on one side. So if you would have something like 2x plus 1, notice I kept with that 2x plus 1 in all three of these problems, how about just equals 5? I'm not even asking you to solve them, but I want you to understand where these are coming from. No solution, the variables match, but the other stuff doesn't. Infinitely many, the variables match, and the other stuff matches too. So it's exactly the same on both sides. Exactly one solution, the variables don't go away. So today's practice problems are from page 15 in that little skinny book, so it'll be a PDF in Schoology for you. I've got these problems for you to solve. The answer key is also in Schoology, and these can be tricky the first time through, so feel free, check your answers as you're going. Make sure that you're checking with that answer key. Make sure that you are showing all of your work. I know that some of you are going to want to skip showing your work. You're going to want to look at the problems and just say, oh yeah, I know how to do that. Please practice them now while they're easy so that when we get to harder stuff, you're good at showing your work. And then don't forget to take the learning check in Schoology when you're all done. If you have any questions, let me know. Have a great day.